You are welcome back to our second class in this pH and pOH journey. If you recall, in our last class, we started about pH and we explained a lot on pH and calculations on pH. In today, we are going to venture properly into the calculations of pOH. Just before we proceed, and you are just joining us for today, kindly subscribe to my channel and click the notification bell for my subsequent content. But don't forget to share and like as we move on. So, let's dive in. If you can recall, in our last class, we were able to come across this formula. We proved this formula in this place. Still the same formula are what we are going to be using in solving our questions under pOH, because pOH and pH will be coincidentally solved together. So, let's look at the first example. Example 1. What is the hydroxyl ion concentration in a solution of pOH 5.5? Now, we are given a pOH of 5.5, pOH to be equal to 5.55, and we are asked to find the concentration of what? Hydroxyl ion. Now, looking at this formula, which one will be suitable to use? We are given pOH. We want to find this. So this formula is suitable. That is pOH will equal to minus log of the concentration of hydroxyl ion to base 10. This pOH is given as 5.55 is equals to minus log concentration of OH minus to base 10. I want to take away this minus because I'm looking for this. Multiply through by minus 5.55 equals to log of concentration of OH minus to base 10. To get my concentration of OH minus, I have to find the anti-logarithm. That's the opposite of logarithm. That's an anti-logarithm. So anti-log of minus 5.55. Since I'm looking for anti-log of this one, this will not be concentration of OH minus. So we take our calculator. In some calculator, you will see second function, 2ND. You press your second function, press your log, and press this minus 5.5 equals to, you see your answer. Or some calculator we have shift. You press shift, then press log, then press minus 5.5. So what do we have? Yes, we are going to have 2.82 times 10 raised power minus 6 molar now. So that's the concentration of OH minus. So let us now see concentration of hydroxyl ion equals to 2.82 times 10 raised power minus 6 molar. That is mole per dm cube. So that is how to calculate the concentration of hydroxyl ion. Example 2. A glass cup of orange juice is found to have a pOH of 11.40. Calculate the concentration of the hydrogen ions in the juice. Now, from this question now, we are given the pOH to be equal to 11.40, and we are told to find the concentration of the hydrogen ion, H plus, unknown. You can see there is no relationship between this in the equation of pOH. But we can still look for one of these formula to start with and then arrive at our final answer. Okay, what if I use this last equation that says pH plus pOH is equal to 14. Now, my pH plus my pOH here is given as 11.40 is equal to 14. So take this one here. I have pH to be equal to 14 minus 11.40. So pH now is equal to, so when we subtract, so what do we have? pH now equals to 2.6. Now we've got pH to be 2.6. We can now apply this formula of pH to be equal to minus log of hydrogen concentration to base 10, that is pH is equal to minus log hydrogen concentration to base 10 will now be equals to, so I want to calculate this, and I have pH now, that is 2.6 equals to minus log of hydrogen concentration to base 10. Now multiply through by negative, minus 2.6 equals to log of hydrogen concentration to base 10. So if I need to get my hydrogen concentration, I have to find the anti-logarithm of minus 2.6. Now I have anti-log of minus 2.6. So it gives me concentration of hydrogen ion. So concentration of hydrogen ion now will now be equal to when you press the anti-logarithm of minus 2.6, we have 2.51 times 10 to the power minus 3 mole per dm, that's the molar. Now in this case now, we are able to get the concentration of the hydrogen ion in the juice. You can as well start your calculation with this pOH. Since you are given the pOH here, you can use this one now to get the concentration of hydrogen ion. Then apply this equation. You can also get the concentration of hydrogen from that place. Example 3. Calculate the pH and pOH of a solution containing 2 times 10 to the power minus 5 molar hydroxonium ion concentration. Now, to solve this question, we are given the concentration of hydroxonium ion to be equal to 2 multiplied by 10 to the power minus 5 molar. And don't forget, from here, we have to find the pH. The pH of hydroxonium ion is the same thing as the pH of this hydrogen ion. So which means pH will equal to minus log of H3O positive to base 10. We are doing this. We are going to have minus log 2 multiplied by 10 to the power minus 5 to base 10. So we expand this now. Minus log 2 to base 10 plus, open your brackets here, log 10 to the power minus 5 to base 10. So from here, you press the calculator, press log 2. What do we have? So we have minus 0.3010. So minus 5 multiplied by plus, I have minus 5. Log 10 to base 10 is 1. So from here, I can now open this bracket. My pH will be minus, when you open this bracket, we have minus 0.3010 plus 5. So let's use our calculator for this. So what are you going to have? So we have 4.699, approximately 4.70. That's our pH. Now, we've gotten our pH. The next one is to find our pOH. So you can apply this formula in this case, that pH plus pOH will be equal to 14. So our pH is 4.70 plus pOH will equal to 14. So now get this pOH, you take this one here, pOH will be equal to 14 minus 4.70. So our pOH has a value of, so subtract. We have 9.30. So that's how to go about this calculation. Now, you can see how easy it is now to calculate the pOH and also the pH of a solution. If you are just coming across this channel today and you are impressed by what you see, kindly subscribe to my channel and don't forget to hit the notification bell for my subsequent content. Also, do like, share, and leave a comment as you leave. Thank you very much until we meet in the next class.